Hello everyone, this is Swati S, a student of Sri Venkateswara College of Engineering, Bangalore from Computer Science Department. Today I am going to be speaking about my technical seminar topic, which is based on a recent IEEE paper named Endoscopic Ultrasound Image Recognition based on deep learning. The contents which will be discussed in this presentation are introduction, literature survey, existing system problems, proposed system advantages, methodology, result analysis, conclusion and references. So coming to the introduction part, first let us understand what is meant by endoscopic ultrasound system. This is a medical procedure which is generally carried out by a gastroenterologist. In this procedure, the insides of our digestive tracts are examined. This is done by inserting a long, thin, flexible tube called endoscope inside our body through the mouth as shown in the figure. This thin tube contains a camera and light in the end. This camera is used to capture the inside images of our digestive tract. On the end of the endoscope, a probe is present known as ultrasound. This ultrasound sends out sound waves to capture the images of our organs, tissues, and blood vessels. Who needs this endoscope ultrasound system? This is needed to evaluate or diagnose abdominal pain or chest pain, or if there are any cancers of different organs present in the digestive tract, or if there are any digestive tract problems such as inflammatory bowel disease, or if there are any stones or lung diseases, lung cancer, or any pancreatic diseases or swallowing disorders. So, we all know that in the recent medical diagnosis, ultrasound medical imaging is widely used. This medical imaging has evolved in the years with the help of big data and deep learning. Every day, large number of medical images are imported in the medical ultrasound image library. Based on the image data obtained from the extraction of medical information using the latest existing technology, professionals will be able to easily decide and take judgments related to the type of patient disease and how much harm it causes. And eventually, they will be able to figure out relevant treatment methods which is obtained through the help of these image data sets. And we all know that in the recent years, artificial intelligence and computer technology has gradually expanded in the field of medicine. In the latest technology, we are using the common medical imaging equipment which can manually mark the images and it will color specific areas. But still now, we need doctors' experience and knowledge to make judgments in specific parts and some of the organ diseases. Coming to the literature survey, here I have taken a few of the important publications. So the first publication is named Application of a Direct Image Enhancement Method in the Medical Image Classification by Chen Yan and others. In this paper, they have proposed a direct image enhancement technology which is very different from the indirect image enhancement technology that is currently being used in the classification of medical images. The second paper is a medical image classification based on multi-feature fusion in scale space by Lee Bo and others. This paper has proposed a method for classifying images through establishing a Gaussian scale space. This is a medical image classification algorithm based on multi-feature fusion in scale space. Coming to the third paper, medical image segmentation based on improved mathematical morphology algorithm by Lee Ziyang and others. In this paper, they have spoken about segmentation of medical images with the help of morphology and filtering operations. This is basically an improved segmentation algorithm for digital morphology of medical images. Coming to the fourth paper, a cancer image detection method based on faster RCNN by Wang Li and others. This paper introduced an image segmentation algorithm based on faster RCNN neural network which gradually exerted its advantages in the market and it served as an auxiliary diagnosis as well. Coming to the fifth paper, weakly and semi-supervised detection in medical imaging via deep dual branch net by R. Bacallo and others. Here, they have proposed an algorithm which had a significant impact on image recognition. This algorithm was basically a weak semi-supervised detection and dual branch deep learning network algorithm. Coming to the existing system problems, some of the problems which are present in the existing system are This ultrasound imaging can be very challenging to process because of its relatively fuzzy quality, and the difficulty of detecting keyframes will be very large because it has very few features. In the recent years, ultrasound imaging in medical field converts the physical characteristics of ultrasound into an image. However, its effectiveness and impact is very limited for detecting organs which contains bones and gas. Eliminating the interference between them will be very difficult. Since it includes too much of complexity, high professional experience and knowledge is required to give precise judgments, or else it may lead to the risk of misdiagnosis. And labeling errors in medical ultrasound images is also very important because it is dependent on the expertise of professional physicians, and the judgment is challenging to quantify. Coming to the proposed system advantages, in this paper they have introduced a new algorithm for recognizing and detecting ultrasound medical images. Unlike previous methods, the main target and goal in this research paper is to improve image quality and optimize or enhance deep learning algorithms. It is done by using image methods and data mining techniques. And moreover, this method uses image edge enhancement and filtering algorithms to improve image clarity and recognition. And it eventually also reduces the impact of image quality issues such as blur or dots on recognition. Now we have the problem of fewer keyframes of dataset, which it is very insufficient as raw dataset. So this problem is solved with the help of OpenCV transformation and data mining technology. Finally, the improved YOLO V4 a convolutional neural network is used to train and learn the images. This will enhance the accuracy and precision of image recognition, and it overcomes the problems of low efficiency and bias which occurs in human judgments. Coming to the methodology, first we do dataset image pre-processing. Pre-processing means generally we eliminate all the unwanted noise or background disturbances from the images. We take the original dataset and we'll send it to the phase of image framing and equalization. Here image framing is done, and then the image is sent for grayscaling and the sharpness of the image is enhanced. Later histogram equalization is done. The obtained output is sent for the next phase of image filtering and edge enhancement. Here we are using median filter and Gaussian filtering. With the help of these filters, what median filtering will do, it will remove all the salt and pepper noise in the image, and Gaussian filtering will eliminate all the glitches and graininess in the image, and it will clean the image. Later this image is sent to the Laplacian edge enhancement for enhancing the boundaries or the edge portions of the organs, and to eliminate all the unwanted noise. Later it is considered as the target dataset. A few quality problems are there in endoscopic ultrasound images, that is, interference and noise interference is caused by useless blur of the image itself. Blur means the unwanted parts which will arise because of the modification in the images. Then image blur and ghosting caused by image framing. Image blur means there is no proper clarity in the image, and ghosting means very big dots are formed on the image because of the reflection of light to the lens. And then the local salt and pepper noise and global Gaussian noise of the image is there. Local salt and pepper noise means small black and white dots are formed on the images which will decrease the quality of the image, and it will not allow the image features of the images to be enhanced and recognized properly. Coming to the acquisition of the data set, so at present there are very few data sets of medical ultrasound annotation. So in this article, it is based on the framing and annotation of medical ultrasound endoscopy training video of People's Medical Publishing House. The video data contains the medical classification and annotation of dozens of endoscopic images, including gallbladder, pancreas, etc. It provides a image source for the construction of the dataset. Through the framing of the image and video, enough frames are obtained to form an image dataset. When framing, the video framing algorithm is used for frame extraction, and the interval is set to 1 to 5 frames. This study selected 10 normal organs such as stomach and pancreas as the research and test objects, and finally extracted 3510 pictures with useful frames. Now, the obtained images cannot be directly used for image classification training, as certain repairs and image enhancement should be done. This needs to be further processed to remove interference frame composed of bubbles and other such items, unwanted things in each organ, so that the characteristics of certain organs in different orientation can still be identified even in a complex scene. So in this paper, a visualization tool for generating the dataset labels known as labeling is used, and the region of interest is considered for frame selection, and 21 divided images of organs are labeled. By generating the corresponding XML file, a dataset in WOC format is obtained. Coming to the image graying and enhancement, the color interference in the dataset is composed of red, green and blue, 3 channels, and its characteristics it only indicates the optical characteristics of the image. It cannot indicate the morphological characteristics of the image. RGB image does not help to solve the identification of ultrasonic organs, and the redundant information it contains will increase the amount of features and calculations. In order to reduce the amount of calculation and in order to save time in the future, the image needs to be unified to the grayscale variation range using the formula which is mentioned on the slide. And after the medical ultrasound image is divided into frames, some images will appear blurry and ghosting. This kind of noise will reduce the recognition of the image and increase the difficulty of recognition. To solve the above problems, after the image is grayed, PIL library in Python is used. This is used to enhance the sharpness of the image, and it is used to improve the quality of the definition of the image. As shown in this figure, we can see that the sharpness of the edge portion of the image B is very significant and clearly visible compared to the image A. Coming to the histogram equalization, the grayscaled image will have uneven distribution of brightness. In order to improve the overall pixel grayscale distribution and contrast of the image, it is necessary to transform an image with a known grayscale distribution into a uniformly distributed grayscale image. By improving the irregular distribution of pixels, the range of pixel distribution is enlarged. Contrast of the image is also improved. The steps are carried out uh, by first calculating the probability density function at each gray level using the formula which is mentioned. Then we are using the mapping relationship to get the distribution function value after gray level mapping by using the SK formula. After converting the standard gray value through the mapping arrangement, the histogram is equalized. The number of pixels will no longer be distributed near the black, but it will also be distributed on the gray scale of 0 to 255 range. Histogram before and after equalization is shown in this figure adjacent. The x-axis here represents the gray level, and the y-axis represents the number of pixels in this gray level. After equalizing the pancreas or any other organ image, the gray level and pixel statistics are used to obtain a visual gray histogram. Before equalization, most of the pixels are distributed in the 0 to 50 area. After equalization, it can be clearly seen that the distribution of grayscale histogram is more balanced. Coming to the next, image filtering algorithm. Ultrasound imaging, it will mainly use characteristics of ultrasound reflected in the organs, and it can distinguish different organ contours. The image has interference mainly caused by speckle noise. This kind of noise, it cannot be eliminated by physical methods. It can only be processed by the method of imaging. In this article, the graininess and glitch interference in the ultrasound images are considered as noise points. In order to reduce the impact of this kind of noise, Gaussian denoising is adopted, and then median filtering is used. First, but however, this Gaussian filtering, it cannot remove salt and pepper noise. So in order for the response to this situation, it uses median filtering as supplementary method to further remove the salt and pepper noise in the image while retaining the edge features of the image. So you can see the filtered result in the diagram alongside. Compared with image A, the blur and salt and pepper noise of the processed image B are greatly weakened, and the joint filtering effect is also good. Coming to the next edge extraction and enhancement algorithm, the recognition of endoscopic images is mainly to judge the ultrasonic appearance characteristics of different organs and membrane structures. The main high frequency information is the changes in the pixel gray levels at the edges and the contours. So here we apply Laplace operator to construct a convolutional kernel which will help to detect all the edges of the organs using this above formula which is mentioned. So here in the diagram we can see that the convolutional operation can extract the edges of the image, and the edge features of the image are preserved, and the features are also further enhanced. Coming to the next, a convolutional neural network. First, we are taking the improved medical imaging dataset as the input. This is passed on to the data mining and expansion phase. Here, a random image operation transformation algorithm are used in the image processing to generate variations of an input image. It is basically used to increase the size of a training dataset for machine learning models, and it is used to increase the robustness of the models. Then it is sent for the mosaic data enhancement. Mosaic data enhancement, it is a technique to generate large datasets for training machine learning models. This process, what it will do, it involves taking a set of images, dividing each of them into smaller tiles, and then rearranging these tiles to create a new larger image, and this creates a large number of unique images that can be used for training, and it is often used to improve the performance of the object detection. Later, this image is sent to the next phase of YOLO V4 detector network and framework construction. Here, a backbone network is used, which is a deep neural network. It is used as a feature extractor for various computer vision tasks. As the term only suggests, backbone means this network serves as a foundational structure upon which additional layers and modules are added to achieve the desired goal. CSP Darknet is a backbone network. The full form of CSP is cross-stage partial network, and Darknet 53 is a popular network used in YOLO V4 object detection system. Then coming to the SPP and PANETs, these are the networks which are used for object detection and segmentation task. The full form of SPP is spatial pyramid pooling, and PANET stands for pyramid attention network. So coming to the next, YOLO head construction. YOLO stands for you only look once. It is a popular object detection algorithm that can detect objects in an image with a real time speed. Head of the YOLO refers to the final layers of the network that generate the object detection predictions. So now the resultant image set obtained by combining all this is sent to the next phase of network evaluation and improvement. Here various types of average precision and mean precision calculations are done to these images, and then they are exported. If these images are accurate successfully, and if they meet the requirements, then only the evaluation result output is obtained, or else they are resent again for improvement, and the whole process is revisited once again. Now coming to the construction of YOLO V4 network framework, the construction, it mainly includes backbone network, SPP, PANET network, and a prediction network. The backbone network is used to extract features. SPP participates in pooling, and PANET mainly participates in feature fusion. The YOLO head part is mainly used for forecasting. And SPP uses pooling to check the feature layer convolution. PANET is a segmentation algorithm used to improve the features of the target detection object and realize the repeated extraction of the features. The feature layer dimensions designed using YOLO network are obtained in the form of 3D images with the values which are shown in the figure. This training forms a convolutional neural network which is suitable for endoscopic ultrasound samples, and it also performed well in the experiment. Coming to the training preparation data mining part, the endoscopic ultrasound images contains both characteristic frames and useless frames. Characteristic frames are the organs that have been correctly marked in the image with fewer interference items. However, the number of such items is very small. In order to solve this kind of problem, data enhancement algorithms are used. Now, data enhancement is based on open CV function library to perform random inversion, rotation, and scaling and other operations. And mosaic data enhancement method is used, as I already said you before. The principle here is to use image stitching to cut partial pixel areas of 4 images and stitch them together into one image. That is, 4 pictures are calculated each time, so the batch time is it will not be large, and it will save the time for calculation, and it will reduce the unwanted calculations. During forward propagation and backward calculation, neural network updates model information. It will calculate the loss value. All this are done to reduce the amount of calculation and to avoid the overfitting of the calculation. So, coming to the result analysis, in order to verify the effect and accuracy of training and the detection ability of this improved YOLO V4 neural network which we use now, it is necessary to judge the degree of overlap between the detection frame and the target recognition of the real frame. It is done by using a ratio known as intersection ratio IOU, which is calculated by the formula IOU is equal to S delta by SU, and the precision of the model is calculated using the formula P is equal to TP by TP plus FP. TP means the detected result is positive sample, and FP means the detected result is negative sample. Now, a single index has certain limitations on the evaluation of the model, and effect of target detection should be judged under the confidence level. So, here we introduced precision P, recall rate R, and average precision AP, which are represented in the PR curve graph diagram, which is shown in the slide. Here, abscissa represents the recall rate and the ordinate represents the precision rate. It can be found that the positive sample threshold point, it shifts to the left, and the value of the precision is initially very close to 1, and recall rate is very close to 0, and the average precision of normal pancreatic lymph nodes is relatively very high, like approximately 95.52%. Coming to the conclusion, this paper proposes a method for ultrasound endoscopic image recognition system based on data mining and deep learning. The image pre-processing algorithm is used to improve the quality of the ultrasound endoscopic images, and we also use the data enhancement algorithm in the OpenCV function library to expand the number of training datasets, and the mosaic data algorithm is introduced to improve the training efficiency and to solve the problem of low recognition efficiency. We use the cosine annealing algorithm to avoid overfitting of the result. So finally, we can say that this algorithm is effective, very helpful for effectively identifying the organs in the endoscopic ultrasound images, and it can identify cancerous cells or any other parts which are present in the organs with high accuracy and precision. So these are some of the references which I used mainly. Thank you for watching till here.